Hi there, today I'll be covering topic 1.1 from A to I of wjec AS chemistry. So we'll be looking at atomic structure, radioactivity, and half-life. Atomic structure. Atoms are made of three fundamental particles: the proton and neutron, which exist in the nucleus of an atom, and the electron, which surrounds the nucleus in shells. So you'll already be aware of the relative mass and charges of the particles, but there's the table, just in case you've forgotten. Okay, so elements in the periodic table have an atomic number A and a mass number Z. So let's look at lithium. Lithium has an atomic number of 3. This tells us that lithium has 3 protons. Since the number of protons equals the number of electrons, lithium has 3 electrons. So we can work out the number of neutrons lithium has by doing Z take away A. So that's 6.94 take away 3, so we get 3.94 neutrons in the nucleus of a lithium atom. So the atomic number is the number of protons in the nucleus of an atom, and the mass number is the number of protons and neutrons in the nucleus of an atom. Isotopes have different mass numbers because of the different number of neutrons, so we can call them virial neutron content. They have different mass numbers, like I mentioned, and chlorine is an example of this, as shown by the table below. Chlorine has the same number of electrons in both isotopes, the same number of protons in both isotopes, but as you can see, the number of neutrons vary, as in Cl35 it's 18 neutrons, in Cl37 it's 20 neutrons. Radioactivity. So, radiation comes from unstable isotopes. This is because the nuclei randomly disintegrates and emits either alpha, beta, or gamma radiation. So they have different properties, as shown by the table below. An alpha particle is a positive helium nucleus, so it has a mass number of 4, and it's the least penetrating radiation and is stopped by a piece of paper. A beta particle is an electron, which is a high energy electron actually. It's stopped by a thin sheet of metal, which can be 0.5 centimeters of aluminium. Gamma rays are high energy electromagnetic radiation. Their mass is negligible, and it may take more than 2 centimeters of lead to stop this radiation. This image shows that if a radioactive source is placed near a positive metal plate and a negative metal plate, the beta electron, being an electron which is negative, tends to attract towards the positive plate, and the alpha radiation goes towards the negative plate because it's a positive helium nucleus, but the gamma radiation just doesn't tend towards neither. Okay, so from this radiation that's emitted, we can form radioactivity equations. This can only be made for alpha or beta radiation. This is because their emission results in a new nucleus forming, therefore a new element. So the new element formed in alpha radiation has a mass number which has decreased by 4 and an atomic number which has decreased by 2. In beta radiation, the mass number is unchanged and the atomic number increases by 1. And you can see that the mass number is unchanged in beta, as in the equation below, nitrogen and carbon have the same atomic number of 14. Half-life. Half-life is the time taken for half the atoms in a radioisotope to decay. So we'll look at the example below. Strontium-90 has a half-life of 27 years. A. Calculate the time taken for the activity of the isotope to decay to 1/16 of its original value. So, that being said, we always start from 1 and keep half in to get the fraction in the question. So start from 1 and half, and we'll see how many jumps there is. So half of 1 is a half, that's our first jump. Half of a half is a quarter, that's our second jump. Half of a quarter is an eighth, that's our third jump. And half of an eighth is a 16th to get the number that we wanted. So that's 4 jumps in totals. So it had a half-life of 27 years, and to get 1/16 of its original value, that's going to be 4 half-lives as shown by the number of jumps. So we do 27 times 4, which is our answer of 108 years. So B, calculate the mass remaining after 81 years if 1.6 grams are originally present. So A, firstly we work out how many half-lives that is. So we do 81 years over 27 years, which is 3 half-lives. So the number of half-lives actually in this case tells us the number of jumps, so we already know that we're going to do 3 jumps. So we go backwards because it says the mass remaining, so we're decreasing. So half of 1.6 is 0.8, half of 0.8 is 0.4, and half of 0.4 is 0.2 grams, which is our answer. So 0.2 grams remains after 81 years if 1.6 grams are originally present. Radiation exposure. So we all receive background radiation, but where does this come from? So you need to know that it comes from naturally occurring radioisotopes or man-made radiation, and it can come from space. So all radiation is potentially harmful, especially high energy beta and alpha radiation. It's really good that alpha radiation can't penetrate through the skin because that is the most toxic radiation out of the 3. So why is radiation exposure harmful? This is because it causes the chemical bonds in a cell to break. This can lead to mutations and can potentially lead to cancer. So, as well as having disadvantages of radiation, there are also benefits. So in medicine, cobalt-60 is used in cancer radiotherapy. So gamma rays are fired at cancer cells, which kills them and prevents a tumor from developing. Also, iodine-131 is a useful tracer. It's used for people who have a thyroid gland problem, and it's used to study the uptake of iodine in the gland. Getting away from medicine, there are also other benefits of radiation, such as in radiocarbon dating. This uses the rate of carbon-14 decay and the activity that remains in an organism to calculate its age, which can be useful. And then there's also analysis, which is useful as it uses isotopes to find the mass of a substance in a mixture. So that's it for topic 1.1 from A to I. Thanks for listening, and I'll be uploading a video on the rest of topic 1.1 soon, so keep a lookout. Bye!